So today our concept is merges. So merging is nothing but yesterday we have seen combining the data sets vertically, right? Like stacking the data sets we have seen. So today we'll be saying merges. Merges is nothing but combining the data sets horizontally. Okay. So here let us take an example first. In merges we have 5 different kinds of merges. 1, 2, 1 merge without relation. Okay. 1 to 1 merge without relation. Next. 1 to 1 merge with relation, and then 1 to many. So rest all are except 1 to, in 1 to 1 only we have without relation and with relation, rest all with relation only. Okay, with relation, many to 1 with relation, and many to many. These are the different kinds of merges. Okay, many to many with relation. These are different kinds of merges that we have. Okay, now we'll see one by one. 1 to 1 merge without relation. First we'll see that. Let us take an example for that. So here we have two data sets called M1 and M2. Okay, M1 and M2 with variables PID, age and gender in M1, and in M2 we have race, height and weight. These are the variables. Okay. Now in 1 to 1 without relation, how it will merge the data means, let us take this M1 data. Okay, and this is our M2 data, right? This is our M2 data. Now, in 1 to 1 without relation, this is the first observation from the first M1 dataset, right? And this is the first observation from M2 dataset. So the first observation from M1 and the first observation from M2 will merge like this. Okay. And now this is the second observation of M1 and this is the second observation from M2. These two will merge. Okay. Third observation from M1 and third observation from M2 will merge. Fourth observation to fourth observation. Okay. And fifth observation to fifth observation. So in M1 we have 6 observations and M2 we have only 5 observations. So it merged. And for the last observation to M1 there is no data, right? So you will get the missing values. Clear? 1 to 1 merge without relation. So the first observation to the first observation in first data set, the first observation from the second data set will merge. Clear? Hello?
Yes, Pavani.
Clear? 1 to 1 without relation. Okay. Yeah. So in order to get this output through programming, okay, data M. So you can create a new data set. Okay. So here we'll create a new data set called M. We are merging the data, right? Merge. So first we want M1 data to be displayed and then M2. So merge M1, M2. Okay. And run. That's it. Clear?
Yes.
So if you want to print it in the output window, write a program called proc print data equals to M and run. Okay. See, first observation to first observation, second observation to second observation, third to third, fourth to fourth, like this. Okay. For sixth observation, it's all missing data. Clear?
Yes.
Okay. This is 1 to 1 without relation. Coming to any merging with relation. Okay, with relation. When you are doing merges with relation, you should have at least one common variable. You should have at least one common variable. Like here you are merging these two data sets, right? Make sure that in both the data sets, you are having at least one common variable. Okay. Clear? So here we don't have any common variable, right? Let us, sorry.
No, I said got it.
Yeah. So let us take these two data sets. Okay. M1 and M2. So here if you see M1 and M2, here what are the common variables that we have? Here PID, age and gender, here PID, race, height and weight. So what is the common variable that we have in both the data sets? we have PID as the common variable. Okay, now based on this PID, we'll be doing the merging. 1 to 1 is nothing but one observation in first data set, only one observation from the second data set will merge. Okay, to one observation in the first data set, only one observation from the second data set will merge. Okay, see here. Okay, now here 101. And here this is the second, this is first M1 data set and this is M2 data, right? So 101 and 101. So this data will go and merge here, okay, based on the PID value. Here 104, this is 104 data. So based on PID value, okay, 103, this is 103 data, okay. So based on PID value, okay, 105. This is 105, okay, based on the PID value. Clear? Now here for 102 and for 106 you will get the missing data, okay. Here we are taking a common variable, right? What is that common variable? PID. So by PID you will write here, okay. So it will merge the data by PID, okay. But whenever we are using by statement in any program, we have to sort the data, no? So proc sort data equals to M1 by PID and run, okay. So same, you have to sort the second data set also. You're merging M1 and M2, right? So both M1 and M2 data sets need to be sorted, okay, by PID. See, for M2, for 102 and for 106, you are getting the missing values. Clear?
Yes, ma'am.
Okay. Yeah. Now this next one is one to many with relation. One to many is nothing but to one observation in the first data set. Okay, many observations from the second data set will come and merge. Okay, to one observation from the first data set, many observations from the second data set will merge. Let us take an example for that here. Okay. So these are the two data sets. Let us say this is M1 and let us say this is M2. Okay. So in M1 we have PID, parent name and income, and in M2 we have PID, kids name, birth, age, weight and sex. Okay. So this is the information that we have. Now if you want to merge these two data sets M1 and M2, see here one to many. One to many is nothing but to one observation from to one observation in the first data set, many observations. If you take PID, see for PID 1, he has like 3 kids. Okay. So to this PID 1, many observations from the second data set will merge. No, all these 3 observations from the second data set will merge. Okay. So to this second PID, here how many observations are there? With PID number 2, 3 observations, right? So all these 3 observations from the second data set will merge with the single observation in the first data set. Clear? One to many?
Yes, ma'am.
Yes, no? So same programming here, M1 and M2 by PID. Okay. Okay, see, to one observation, this is all one observation only. Bill, PID 1. But many observations from the second data set are getting merged. Okay. See here also, it is the same observation in M1, but many observations from M2 are merging. Okay. Now, what is the next one? Many to one. Many to one is also almost similar. Okay. So many observations. So if you write here M2, okay, and if you write here M1, that is many to one. Okay. To many observations. Okay. To many observations in the first data set. Single observation, one observation from the second data set will come and merge. Here if you see both Bob and Bob, like these three are three different observations, right? But to all these three different observations, only single observation will come and merge. Okay. That merging we call as many to one. Okay. You see here, these three are three different observations, but to all the three different observations, only single observation is getting merged. Okay. This we call as one to many. Sorry, many to one. Clear? Hello?
Yes, for me.
Clear, no? Okay. The next one is next, what is the final one? Many to many, right? In this many to many, we'll make use of the in operator also. Okay. So let us take an example for this many to many. I'll clear all this. Okay. We'll take this example for many to many. Okay. So here we have two data sets called M1 and M2. Okay. With variables PID, date and disease. And here we have PID, date and medicine. Okay. Many to many. Many to many as in to many observations from the first data set will merge with many observations in the second data set. Okay. So many observations. If you see here, see for 102 here we have three observations, right? Many observations. So here for 102 we have three different observations, which is like many observations. Okay. So many observations from the first data set will merge with many observations to the second data set. Okay. So when we are doing this many to many merge, if we have at least two common variables, then the merging will be more accurate. Okay. So if we have like at least two common variables when we are doing many to many merging. Okay. For rest of the other three merges, okay, if you have at least one common variable, that is fine. But many to many, we should have at least two common variables. Okay. Then the merging will be accurate. Remember that point. Here, what are the common variables that we have? PID and date. Okay. Data M, merge M1 and M2. Okay. By PID. What are the two common variables? PID and date. Okay. And date and run. Okay. By PID.
Sorting.
Sorry?
Sorting.
Yeah, sorting we have to do. Proc sort data equals to M1 by and run by PID and date. Same. By PID and date and run. Okay. So what result that you will be getting means by PID and by PID and date, right? These are the two common variables. See here, if you write this program, the result that what you will be getting is for 101 16th November. Okay. Here also 101 16th November. This is nausea and this is the value, right? So it will merge here. Here 102 16th November, 102 16th November, antacid. Okay. So you will get it here. Next 102 17th November, 102 17th November. Okay. So this is the disease and this is the medication that they have given. 102 18th November, 102 18th November. Okay. Next. 103 18th November, 103 18th November, 103 18th November is aspirin. 103 18th November is aspirin. 104 19th. 104 is not there here, no? 105 aspirin. So 105 17th November, 105 17th November aspirin. Okay. So this is 104, right? So for 104, we don't have the information of what the disease is, but we have the medication value, right? So you'll get a missing value here. Okay. So you will get a missing value here. Okay. Now for 101 17th December, we have the information about the medication. So we have the information about medication, but not about the disease. Okay. So you'll get the missing data here. Clear? So
Yes.
finally, you will get all the observations from both the data sets. Okay. So by PID and date, wherever it can match the data, it will match the data, and wherever there is no information, it will give you the missing value. Okay. So you will get all the data from both the data sets. Run the program. So if you want to print in the output window, you can print by writing proc print data equals to m. Okay. By sorry. Data. Okay. See. So you are getting the missing data. Clear?
Yes.
Okay. Now the next one is, suppose we want only the common observations. Okay. Common observations as in, let us take this data. This is okay. Now common observations as in, see here 101 16th November nausea, right? For this 101 16th November dopamine. 101 17th December. 101 17th December it is not there. 102 16th. 102 16th November antacid. 102 16th November antacid. 102 17th November. 102 17th November sodium bicarbonate. 102 18th November. 102 18th November dopamine. Okay. 18th November dopamine. Next 103 18th November. Okay, aspirin. 103 18th November aspirin. 105. This is this one, right? So here if you observe, this observation is present in M2 dataset but not in M1. Same with this also, no? Present in M2 but not in M1. If you take this 103, this is present in M1 but not in M2. Okay. Okay. So this observation is present in M1 but not in M2. If it has M2, then you would have got value, some value here, no? For medication. Okay. So these two observations present in M2 but not in M1. So common observations are nothing but this. In other words, you can say without any missing values, you will get all the data. Okay. Clear? Hello. So is
Yes,
everyone
ma'am.
clear like what is common data?
Yes.
In order to get the common data, here we have to make use of the in operator. In equals to A. A is nothing but alias name. Okay. We are giving another name. That's it. You can say here in equals to B. Okay. Not only A and B, if you want to give X or Y or X and Y or C and D, like whatever alpha, like whatever letters or characters you want to give, you can give. Okay. So this is nothing but alias name. Okay. In A and in B. By PID and date. Here you have to write if statement. So we want a data, common data. Common data as in it should be present in both A and B, right? It should be present in both the data sets. So write here if A, sorry, if A and B. Clear? So just write if A and B. Okay? Or else you can say like if A equals to 1 and B equals to 1. You can write either way. So that you will get only that common data. See? You are getting only that common data. Okay? Now, the next one is, for suppose say you want only the data from M1, okay, and matching data from M2, okay. So matching data as in See, based, so here what we are giving in by statement, by PID and date, right? So by this PID and date, whatever is the common data, that only that data it will return you. Okay. Um, okay. So we want only the data from M1, okay, like all the observations, all the data from M1 and matching data from M2, as in, we'll do again the output thing. So this is the data from M1. Now take the data from M2 also. Okay. So we want all the data from M1 and matching data from M2. So matching data as in 101 16th November. Is it there? Yes, 101 16th November. So you'll get this value. 102 16th November. It is not there. It is there. 102 16th November. Okay. Next. 102 17th November. 102 17th November. Next one is 102 18th November. 102 18th. 102 18th November. Next one. 103 17th. 103 18th is there. Okay. 103 18th. And 105 17. Okay. And 105 17. Okay. So you'll get this data to the output. Okay. So you are getting all the observations from M1 and matching data from M2. Okay. So in order to get that data, what you have to write is just write here if A equals to 1. A is nothing but M1, right? So if you write if A or if A equals to 1, anything will work. So it will return you the all the data from M1 and matching data from M2. Okay. Clear about this? Hello?
Yes, ma'am.
Yes, no? Okay. The next one is, yeah. Suppose say you want all the data from M2 and matching data from M1. Okay. In that case, write here B equals to 1. Okay. So that you will get all the data from, see, all the data you are getting from M2 and matching data from M1. Okay. Clear?
Yes.
Okay. Merges is like very short concept, but this concept is very important in real time. Okay.